Hello, welcome to the ninth lecture for the Mathematics Class 11, Chapter 7, Binomial Theorem. So, we have seen the entire and concept of binomial expansion. Okay, how do we expand when we have been given terms which are raised to some power of index? Okay, uh, using those expansion formulae, and also we also understand what is binomial theorem. We have solved a lot of sums, so this class will also be focused on solving solved examples. So some of them have been asked previously in entrance exams, and also it will help you to develop the understanding, and also different few other concepts that are related to the few terms related to binomial expansion. So let's see. So the first question over here that we have is, what is the sum of the coefficients of all odd degree terms in x plus x cubed minus 1 the whole raised to 5 plus x minus x cubed minus 1 the whole raised to 5, where x is greater than 1. Okay, so this is the question that we have. So these are two, separate binomial expansions, and we have to find the sum of the coefficients of all the odd degree terms. So every time your x, has an odd degree, okay, we will try to find the sum of those coefficients. Okay, so let's first say let y is equal to root of x cubed minus 1. Okay, so this entire term, okay, the second term in both the brackets, we are considering it y to simplify our, solution. So then you will have x plus y raised to 5 plus x minus y the whole raised to 5. Now we will do the binomial expansion of this. So the first one will have x raised to 5. Okay, so because you have C 5C0 as 1, so we'll keep that out, and y does not have any power as such over here. Then you'll have 5C1 x raised to 4y plus 5C2 x raised to 3 y raised to 2 plus 5C3 x squared y cubed plus 5C4 x y raised to 4 plus 5C5 y raised to 5. Okay, and now we have a plus sign between them, and now we'll have a negative, we have negative y everywhere. Okay, so keep in mind about that negative sign when you are expanding. So now what we will have is x raised to 5. Now, since we will have y raised to 1, so the minus sign will remain. So you have minus 5c1 x raised to 4y. Okay, and now we will have minus y raised to 2. Okay, so that will become your positive y. So then the sign outside will be plus 5c2 x cubed y squared. And then again, you will have an odd degree, odd power for minus 5. So you will have minus 5c3 x squared y cubed plus 5c4 x y raised to 4. And then again, minus, since we have a y raised to 5, 5c5 y raised to 5. Okay, So over here, we can see that some of the terms will get cancelled because you have plus and minus. So for that, we'll see for this expansion, this term will get cancelled and this term will get cancelled and also this term. Okay. So what we are left with is we'll have, since it's addition, so you have 2, 2, 2. So we keep 2 out and write all the terms inside. So you have 2x raised to 5 plus 5c2 x cubed y squared. And the last one that we'll have is 5c4 x y raised to 4. Okay. So now we will put in the values for, y as well as your coefficients. So what you get is, first let's put the values for the coefficients. So you have 2x plus 5 and your 5c2 becomes 10x cubed y squared. And you will have 5c4 as 5x y raised to 4. Now we substitute for y. So you have 2 and you have x raised to 5 plus 10x cubed. Your y was what? Y was equals to cube root of x square, square root of x cube minus 1. Okay. So if you square this, what you get is x cube minus 1 plus 5x. Now y raised to 4. So this raised to 4 will give you x cube minus 1 the whole square. Okay. So this is what we get. Now we will, open up the brackets. So what we have is 2x raised to 5 plus over here you have 10 x cubed. So this is x raised to 6 and then you have 10 x cubed. Then you have solve for this. Okay, expand the x cubed minus 1 the whole raised to 2. So you have 5x outside and you will have x raised to 6 minus 2x cubed plus 1. Then you expand that 2 plus 10x cubed plus over here this will be 5x raised to 7 minus 10 x raised to 4 plus 5x. Okay, now we will, try to see for all the, we will add up wherever we have any, common power. There is actually no common power in that manner. So what we can do is we just write in the ascending order of all the powers. So we have 5x raised to 7 plus 10x raised to 6 plus x raised to 5 minus 10x raised to 4 minus 10x cubed and we have plus 5x. So out of these, we have to find the sum of the coefficients of all odd degree terms. Okay, so which are the odd degree terms? You have 5 over here, 5x raised to 7. Then you have x raised to 5 is the term. And you have 10x cubed minus 10x cubed and 5x. So therefore, sum of the coefficients of odd powers of x is equals to, so we also have a 2 outside, okay, a common 2. So you write 2, and then you write 5 plus 1 minus 10 plus 5. Okay, so what you are left with is, so if you can see 5 plus 5 is going to be 10. So 10 and minus 10 will get cancelled. And what you're remaining with is 2. Okay, so this is your answer. Now let's take another example. Question. What is the middle term of 1 plus x raised to 2n? Okay, So we have seen, that for any general term, okay, P R plus 1, what we have is N C R and A N minus R B R. Okay, so this is something that we know. Now, this is for a general term. What would we get if we, like, suppose we need to find the middle term? Okay, now you will see that, let's take a very simple expansion. So, a plus b the whole square is going to be equal to a square plus 2ab plus b square. And if you have a plus b the whole cube, you have a cube plus 3a squared b plus 3ab squared plus b cube. Okay, so this is the expansion. Now you will see that there are, when n is equals to 2, your total number of terms is 3. And when your n is equals to 3, the total number of terms is 4. Okay, so for every even power, okay, we have odd number of terms. So the middle term over here would be the second term. Okay, so you have exact one middle term for when you have even powers. But when you have odd powers, you will see that there is no particular one middle term. Okay, you have two middle terms over here. So we have to remember, okay, so there is this rule which you can remember, that for even n, okay, your middle term is going to be, okay, so over here, what is your, how will you find what is the middle term or the R that you have to find? Okay, what is your R for the middle term? So when you have 2, so suppose you have 2 by 2 plus 1. Why plus 1? Because we always take R plus 1, right? So we want to find which R is going to give you the middle term. So for R, for the middle term would be n by 2. Okay, so that is 1. And it will be 1 plus 1. So it's the second term. Okay, over here you can see it's the second term. So for even n, the middle term, okay, will be n by 2 plus 1. Okay, so that means this will be actually tn by 2 plus 1 will be term. And for odd power or odd n, you will have two middle terms. Okay, so the first middle term would be your n by 2 plus 1 term, and your t mid 2 will be n plus 2 plus 1 plus 1. Okay, so over here, if you see, your middle terms are actually the second and the third term. Okay, so how do we find the first middle term? So that is n by 2 plus 1. Okay, so it will be what? Actually, this is going to be the entire, sorry, n plus 1. This one. We have to get it into an even part, right? Yeah. So you will have n plus 1 by 2. Okay, and similarly, this one will also be n plus 1 by 2. So what is n plus 1 by 2 over here? N plus 1 by 2. Okay, so that is, you have 3 plus 1, 4 divided by 2, so that is 2. So the first middle term is the second one, and we have the next middle term as n plus 1 by 2 plus 1. Okay, so that is the third term. So this is how you can find the middle terms directly. Okay, so you don't, you can just find out your R easily. Okay, so for even, the R will be n by 2, and for odd, okay, so for odd, you will have two middle terms. So that way you can find it. So over here, we are being asked what is the middle term for 1 plus x to n. Okay, So over here, you can see that our n is 2n. Okay, so this in any way will always be an even term. Even n. Okay, so therefore, your n by 2 plus 1 is going to be n plus 1. Okay, so your middle term, n term is the middle term. So let's find the term. So you will have p n plus 1. Okay, and over here r is going to be equal to n. So what you get is now you will have NCR. So over here the n is 2n, CRR is also n. Okay, and then you will have 1 raised to 2n minus n. Okay, so that will be 1 no matter what your value of n is. So we'll just skip writing the 1, and the next one will be, and the next term will be x raised to n. Okay, why? Because r is equals to n. So this when you solve, okay, so let's just write it here again. T n plus 1 is equals to 2n cn x raised to n. Okay, so if you write expand for the coefficient, what you get is 2n minus 1, 2n minus 2, all the way up to till the time we don't reach your 1 in the factorial form. Okay, and this will be n factorial, and then 2n minus or n factorial is again n factorial, and you will have x raised to n. Okay, so now let's separate, in even and odd, for the upper, for the numerator in the factorial. So you have 2n minus 2, 2n minus 4, all the way up to 4 and 2. Okay, so this will be, let's say, divided by n factorial. Now, if we take the next one, so that would be starting with 2n minus 1, 2n minus 3, all the way up to 3 into 1. And this also we are going to keep as n factorial, and then we have x raised to n. Now over here you can see that if you take 2 out, okay, over here, and what you get is n minus 1, n minus 2, okay, all the way up to here. So we have 2 and 1. So this actually becomes equal to 2 into n factorial upon n factorial. Okay, and this part we just write it as it is. So you have 2n minus 1, 2n minus 3, up to 5, 3, 1. Okay, and upon n factorial, that's used to n. Over here, your n factorial and n factorial gets cancelled. Okay, so over here, what you get is then 2n. Now you can just write it in the ascending order. 1, 3, 5. Look at it. 2n minus 1 in the last. Okay, n factorial x raised to n. Okay, so this is what we get. Okay, let's do another sum. So, question. If the fractional part of the number 2 raised to 403 by 15 is k by 15, then what is k? Okay, so first we will, find for the numerator the expansion of it. Okay, so you can write 2403 in terms of 2 400 multiplied by 2q. Okay, now this you can write as 2 raised to 4, the whole raised to 100 into 8. Okay, so then you have 8 into 16 raised to 100, and that in itself you can write as 8 1 plus 15, the whole raised to 100. Okay, so if we divide, say this is your 1, we divide 1 by 15, what do we get? 8 by 15, 1 plus 15x. Okay, so this x is actually the entire, expansion part. Okay, we'll just keep it at that. Okay, the x is the entire your expansion of everything. So if you, multiply with 8 by 15 and inside the bracket, what you get is 8 by 15 plus 8x. Okay, so we are saying in the question we have said that the fractional part of the number 2 raised to 403 divided by 15 is k by 15. Okay, so now this exactly is actually corresponding to your 2 raised to 403 divided by 15. Okay, so the fractional part of this, this entire term is actually only 8 by 15. So therefore, your k is actually is equals to 8. K by 15 is going to be 8 by 15. Okay, and therefore this should be 15 or 18. Yeah, so this is 50, and what you have as k is equals to 8. Okay, so whenever you are asked a question like this, so you first get into one fractional term and the other as either the entire binomial expansion term, or just a part of it, and then whatever you have been asked to find through the fractional part of that number, you can then get the answer. Okay, let's take another sum. Suppose you are asked which term will be the limit of x in 3 by 2 squared minus 1 upon 3x the whole raised to 9. Okay, just excuse me, I'll have some water. Okay, so if you remember exactly the binomial theorem, okay, so when we do your binomial theorem, so that is a plus b the whole raised to n. Okay, so you have nc0 a raised to n b raised to 0 plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a n minus 2 b raised to 2. And that's all the way, okay, all the terms, and with a general term in between as n c r a n minus r b r plus n c n a raised to 0 b raised to n. Okay, so you can see that this is actually a sum of all these terms. So your expansion can also be represented in the notation form as r is equals to 0 summation over r going from 0 to n. You have n c r a n minus r b raised to r. Okay, so this is what is the, how we can represent the binomial expansion in terms of, summation notation. So this will come handy over here. Now, what will be the expansion in the summation notation over here will be for 3 by 2x squared minus 1 by 3x the whole raised to 9 can be written as summation r going from 0 to n. Sorry, n over here will be 9. So I'll just write 9 straight away. So you have 9. Okay, and then you will have 9 CR and you have A. Okay, A raised to n minus r. So A is 3 by 2 x squared 9 minus r. And your B is going to be minus 1 by 3x the whole raised to r. Okay, so now we will have to find which term will be independent of x. So the term in this expansion where your x is going to be raised to 0 is the term that we need to find. Now for the x to be 0, okay, so for the term independent of x, the powers of x should, or the sum of the powers, I should write, the sum of the powers of x should be 0. Should be 0. Okay. So now over here you can see that already your A has, x raised to 2. Okay, x squared. And you have a minus, x raised to minus 1 in the B term. Okay. So this, the powers, the total powers, the sum of the powers of x, okay, in any during the expansion should be equal to 0 for the term which is independent of x. So therefore, the sum of the powers, okay, so we have 2 multiplied by n minus r, that is for the a part, okay, and over here you will have x raised to minus 1 into r, okay, so it is minus r, and this should equal to 0. So now we have to find the r, okay, we have to find what would be the r. So therefore, this will be 18 minus 2r minus r is equal to 0. So this is going to be 3r is equal to 18. So therefore your r is equal to 6. Okay. So your r is equal to 6. So therefore the required term is, now over here, this, since your r is equal to 6, so this is actually 6 plus 1. Okay. And this will be 9c6. Okay. 9c6. And this will be 3 by 2 x squared 9 minus 6 and minus 1 3 x 1 upon 3x raised to 6. Okay, so let's just solve for it. So your P7 will be, you can, write this 9 into 7 into 8 into 7 into 6 factorial upon 6 factorial multiplied by, you will have 3 factorial, so 3 into 2 into 1. Okay, and this will be what? This will be 3 by 2 x squared raised to the whole raised to 3. So 3 by 2 x squared the whole raised to 3. And this will be minus 1 by 3x raised to 6. Okay, so this you can get as 3, 4, sorry, it's only 4. So 12, 12 plus 12 into 7. 12 into 7 is 84. 84. Okay. Multiplied by. Now over here you will have. Okay, you will take out the bracket. So what you get is 27 by 8. You have x raised to 6 multiplied by. Now you write the minus sign will go away over here because the entire thing is raised to 6, so which is an even power. So what you have is 1 upon. So you have 3 raised to 6. Okay, so over here we saw that 3 cubed is 27. So you can just write 27 into 27 multiplied by x raised to 6. Now over here x raised to 6 and x raised is cancel off. So you can see that now you do have, this term has actually become independent of x. Okay, so you cancel your 27 also over here. So what you get is 84 multiplied by, this will be 8 into 27 is 1 by 216. So 84 divided by 216. So you can, actually leave it as 84 by 216, or you can just write it in terms. Okay, if you are only asked to find, if you're given an, in a way of multiple choice question and you're asked, so you can immediately just write it in the form as 9C6. Okay. Or maybe I'll just write it in the next part because that would be easier. Okay. Or your P7 is going to be 9C6. Okay, so this when you expand, after this, what you get is 1 upon 216. Okay, so 216 in itself is actually the cube of 6. Okay, sorry. Yeah, so you can just write this as 9C6, 1 upon 6, the whole cube. Okay, so if in your MCQ you are given an option like this or a value, so you can, both these answers are the same. Okay, let's do another sum question. Are the coefficients of x raised to p and x raised to q in 1 plus x p plus q the same or different? Okay, so now let's take this as let y p plus 1 is equals to p plus q p p x p and y q plus 1 equals to p plus q p q x q. Okay, so now we will try to find coefficient of the xp and we will find the coefficient of xq. Okay, so coefficient of x raised to p is going to be p plus q cp. Okay, so when you expand this and you write it in factorial form, what is that is p plus q factorial. Okay, you have p factorial and p plus q minus p. So your p and p gets cancelled. So what you're left with is q factorial. Okay. Similarly, your coefficient of x raised to q is going to be p plus q. pq is equals to p plus q factorial upon, you have again, if you just write this down, we will have q factorial and p plus q minus q, so you have p factorial. So over here you can see that these two are of the same form. So therefore, coefficient of x raised to p is equals to coefficient of x raised to q. Okay, so this is a simple sum. You just have to, use a little of your logic to get that sum. Okay, let's do another sum. So, the question is, P is the fractional part of P, where P is 3 raised to 200 by 8. Okay. So, find the fractional part. Okay. So, we have to find the fractional part of 200 by 8. Okay, so this you can write in terms of 1 by 8, 3 raised to 200. Okay, so this will then become 1 by 8, 3 squared raised to 100. This will be then 1 by 8, okay, 9 raised to 100. So then that can be written as 1 by 8, 1 plus 8 raised to 100. Okay, so now if you expand this part, you have 1 by 8 multiplied by, you have 1 plus 100 C1, 8, multiplied by 8, then plus you have 100 C2, 8 squared, plus 100 C3, 8 cube, okay, all the way up to plus 100, 300, 8 raised to 100. Okay, so we just solved a similar, sum just a few slides back. So over here also you can see that this can actually, can be written in terms of 1 plus 8, 1 plus, if you take out 8 common, okay, in all these terms, and the rest of all the expansion terms, okay, all the coefficients and the values of 8 raised to some power, if you just write it as 8x, okay, where 8x is an integer. Okay, so what then this becomes is, okay, is 1 by 8 is multiplied, this whole thing also becomes an integer. Okay, so now we know that this, okay, the fractional part, okay, so this is the fractional part. So this is then equal to, okay, so your P or your fractional part of 3 raised to 200 by 8 is actually equals to 1 by 8. Okay, so this is how you can find, such if you ask questions in terms of, finding the fractional part of it. Okay, so let's do another sum. Okay, so let's take a question. So suppose you're given x plus root 2 raised to 8. Find the middle term. Okay. So we were just looking at it that for even n, p middle is going to be equal to t n by 2 plus 1. Okay, so over here, since we have 8 as n, so your n by 2 plus 1 then becomes 4 plus 1, the fifth term. Okay, so therefore, if your fifth term we are finding, okay, so your T5 is actually T4 plus 1. Okay, so your R then becomes equals to 4. So then this will be your 8C4, and you have 8 N minus R. So you can just, sorry, not A. We will just write the substitute for what is there. Yeah. So you will have 8C4. You have X raised to 8 minus 4, and you have root 2 raised to 4. Okay, so what we get now is 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial into 4 factorial, just expand it and please. Okay, multiplied by your x is going to be raised to 4, and root 2 raised to 4 is going to be 4. Okay, because root 2 squared is 2, 2 into 2 is 4. So then we can get this as 4 factorial gets cancelled, 4 and 4 can get cancelled, 3, 2, 4. Okay, so now what we have is 4 into 7. Okay, so 4 into 2 is 8, 8 into 7, 56, 56 into 5 is going to be 280 x raised to 4. Okay, so this is your answer. So suppose if we, just for example, take this as x plus root 2 the whole raised to say 5. Okay, find middle terms. Okay, so for when n is odd, okay, t middle 1 is going to be t n plus 1 the whole by 2, and t mid 2 is going to be t n plus 1 the whole 2 plus 1. Okay, so let's first find your t n plus 1 by 2. So that is going to be t. Your n is 5, 5 plus 1, 6, 6 plus 6 by 2 is 3, t3. So this is going to be t2 plus 1. Okay, and this is going to give you 5c2 x raised to 5 minus 2, 3, and root 2 we will have root 2 squared. Okay. And so this will be 5 into 4 into 3 factorial upon 2 factorial, and 3 factorial is going to be 6. Sorry, we will keep, yeah, so we have to take out 3 factorial and we can keep 2 factorial. So 3 factorial is cancelled. 2. Okay. And this will be multiplied by 2 into x cube. So this is going to give you 10 into 2, 20 x cube. Okay. So this is going to give you your T3, that is one of the middle terms, is going to be 20x cube. Now the next one is, so if this is T3, then we have to find T4. Okay. So because the second middle term is Tn plus 1 by 2 plus 1. Okay, so T4. So this will be T3 plus 1. So now you can write this as 5C3 x raised to 2, and this will be root 2 the whole raised to 3. So your 5C3 is actually going to be same as your 5C2 value. Okay, so that is actually going to be 10. So you can write 10 into, this is 2 root 2 multiplied by x squared. So this then becomes 20 root 2 x squared. Okay, so you see that by knowing these two formulae, okay, so these related formulae, it is easy for us to find the middle term for any expansion. Okay, however long your expansion is, it's very easy to find. So we will end here today, and this is also the end of the binomial theorem chapter. So hopefully the solved examples will give you more insight into how you can solve for binomial expansion questions. And for keep in mind the formulae that are used, and also some easy tips and tricks that you can use to solve such questions. So thank you for joining this class.